Now let us start with the first subtopic of geometry, that is angles and lines. So whenever two lines intersect, there is some angle between those two lines, and depending on the value of that angle, we have names for those angles. For example, if the two lines are intersecting at an angle of 90 degrees, it is called a right angle. So you can see in the second figure, if the angle is 90 degrees, we call that angle as right angle. Similarly, if the two lines are collinear, or if the two lines are intersecting like this, that is the angle between them is 180 degrees, then this is called a straight angle. So basically the two lines make a single straight line and the angle is called a straight angle. This is 180 degrees. The third special scenario is if the two lines are one on top of the other. So the angle between them will be 360 degrees. And if it is 360 degrees, it is called a complete angle. So these are three special scenarios where the angle can be 90 degrees, 180 degrees or 360 degrees. And these are called right angle, straight angle and complete angle. Now, if the angles are in between these values, so if the angle is between 0 degrees and 90 degrees, then we call it as acute angle. So it looks like this. The angle is less than 90 degrees. So any value, maybe 25, 30, 62, any such value is acute angle. Then if the angle is between 90 degrees and 180 degrees, it is called obtuse angle, such as this. So you will see that the two arms are spreading apart. The angle is more than 90 degrees. And the third scenario is if the angle is between 180 degrees and 360 degrees. So this fourth figure where the angle between the two arms is 240 degrees. This is called a reflex angle. So on one side of these two arms is 120 degrees, which is obtuse angle. And on the other side, we have 240 degrees, which is the reflex angle. So this is how we name the value of angles. Now here are some special properties. So if we have a straight line and on top of that line, we may have several other lines at a particular point. So here the sum of all the angles on one side of that line is going to be 180 degrees. So we know that about a point, the total angles are 360 degrees. If we make a straight line, on one side there will be 180 degrees and on the other side there will be 180 degrees. So this is one property that we must remember, that on a straight line, on one side of the straight line, the angles will always be equal to 180 degrees. The second point is sum of angles around the point is 360 degrees. So if there is a single point, the sum of all the angles about that point will be 360 degrees. Then there is this nomenclature of complementary angles. So if there are two angles and we add them and we get a value of 90 degrees, then we say that these two angles are complementary angles. Similarly, if the sum of those two angles is 180 degree, then these are supplementary angles. So in the figure you can see that if the two lines were at 90 degree and there is some line in the middle, the sum of these two angles, this will be is equal to 90 degree. So these two angles are complementary angles, and here we have the sum as 180 degrees, as we have said that angle on one side of a straight line add up to 180 degrees. So these two angles, these will add up to 180 degrees. So these are supplementary angles. Now when two lines are intersecting each other at an angle of 90 degrees, then those two lines are said to be perpendicular to each other. For example, here AB is perpendicular to BC and we denote perpendicular by this symbol. So AB is perpendicular to BC, that is at the point B there is an angle of 90 degrees. So we are covering all these terminologies because these are mentioned in the questions. So it may be mentioned that a line is perpendicular to another line, or angle A and angle B are complementary angles. We must know the meaning of these terms so that we can solve those questions. Now let us understand what are line bisectors and angle bisectors. Suppose there is a line AB and another line CD is dividing the line AB into two equal parts. So in this figure, AF is equal to BF. So this line CD is called a bisector of the line segment AB. A line which will bisect another line segment into two equal parts is called a bisector of that line segment. Similarly, if there is a line which is dividing an angle into two equal parts, that is called an angle bisector. So angle AOB is divided into two equal parts, angle AOC and angle COB. This division is done by the line CO. So CO is an angle bisector of the angle AOB. Now the third point is extended from this second point only, that if we have an angle bisector, so we had this angle bisector CO, any point on this angle bisector will be equidistant from the two arms of the angle. So suppose we take a point D on CO. Suppose this point is D. Now the distance of this D point from BO is this perpendicular line, and the distance of D from AO is this perpendicular line. So these two perpendicular lines will have equal length. That is, the distance of point D from AO and BO will always be same. Now in the third figure, you can see that RS is a line segment which is bisecting line segment PQ, and it has a special property, that is, it is making a 90-degree angle with the PQ segment, which is making an angle of 90 degrees. This is called a perpendicular bisector of the line segment. So a perpendicular bisector has two properties. One is it will divide the line segment into two equal parts, and the second is that the angle it will make with the original line segment is 90 degrees. Another property of this perpendicular bisector is that if you take any point on this perpendicular bisector, so I have taken a point R on this perpendicular bisector, the distance of this point R from P and from Q will always be equal. PR is equal to RQ. So any point on this line segment is going to be equidistant from the two ends of the initial line segment. Now we are going to cover some properties of parallel lines. So parallel lines are basically two or more lines which always maintain equal distance from each other. So you can see that PQ is one line and RS is a line parallel to the PQ line. This means that these two lines are never going to intersect with each other. And to denote that these two lines are parallel, we use the symbol of two lines. So PQ is parallel to RS. Now when we have two or more parallel lines and there is some other line which is intersecting all these parallel lines, this intersecting line is called a transversal. So any line which is cutting two or more parallel lines in a plane is called a transversal. And when we have a transversal, the transversal creates some special conditions, some special properties. So in this scenario, when this XY transversal is intersecting with the line PQ, it is making four angles. So if you look at this particular point M, there are four angles created: PMX, XMQ, QMN and PMN. These four angles are created. The first property is that the opposite angles are going to be equal. So angle PMX is equal to angle QMY. These two angles are equal. Similarly, the opposite angles PMY and M, Q, these two are equal. 1 and 3 are equal. 2 and 4 are equal. And you can do similar exercise on the point N also. The opposite angles on point N will also be equal. The second property is that corresponding angles are equal. Now, what are corresponding angles? If you look at angle XMQ, the corresponding angle to this angle will be angle XNS. How are these corresponding? So, XY is intersecting with PQ and angle XMQ is being created. And in the similar fashion, it is intersecting with RS, and a very similar looking angle is MNS. These two lie on the same side of the transversal. These corresponding angles are equal. You can do this for other corresponding angles also. So if you look at the angle on the bottom, angle QMY is equal to angle SNY. If you go to the left, angle XMP is equal to angle MNR. Similarly, on the lower left side, these two angles are equal. The third property is that the sum of interior angles of the same side of the transversal, that is going to be 180 degrees. So if you look at the interior angles on the same side, PMN, this is one, and the other is MNR. These two angles are on the same side of the transversal, and these are interior angles. The sum of these two is going to be 180 degrees. And you can easily see why this is 180 degrees. Angle 2 is equal to angle PMX, because we saw that in the second property because of corresponding angles. And sum of 1 and 2, because these are on the same side of the straight line, this is 180 degrees. So therefore, sum of interior angles on the same side of the transversal are always going to be 180 degrees. Now the fourth property is that the sum on the exterior angles of the same side of transversal is also 180 degrees. And the same logic applies here also. So angle XMQ and angle SNY, sum of these two angles is also going to be 180 degrees. And the logic is same. Now when we have more than two parallel lines and there are more than two transversals also, a special scenario arises where we have multiple intercepts. Now these intercepts satisfy a certain condition, and the condition is that the proportion of line segments cut by these parallel lines, these will be in same proportion. So PQ by QR, these are the segments cut by the parallel lines on the first transversal, and JK and KL, these are the segments cut by the same parallel lines on another transversal. The ratio of these segments will be same. So PQ by QR is equal to JK by KL. So if you have multiple parallel lines and multiple transversals, so two or more transversals, the ratio in which those will be cut by those parallel lines will be same in all the transversals. With that, we have covered a lot of important concepts. Now let us try to do some examples so that we understand the theory better. The first example is saying that there is an angle which is equal to 1/3 of its supplement. What is the measure of this angle? So suppose the angle is X and its supplement is therefore 3x. Angle is equal to 1/3 of its supplement. So supplement is 3x. And the property of supplement is that x plus 3x, the sum of two supplementary angles is 180 degrees. So 4x is equal to 180 degrees, x is equal to 45 degrees. So the angle is 45 degrees and the supplement is 135 degrees. So generally in exams, instead of saying that the sum of two angles is 180 degrees, they will tell you one angle and they will say that the other angle is a supplement of that angle. So you must know that a supplement means that the sum of those two angles is 180 degrees. Similarly, complement means the sum of those two angles is 90 degrees. Now in this example, it is given that OP, this line OP, bisects angle BOC and OQ bisects angle AOC. So I have marked that these two angles are equal and these two angles are equal. And we have to find the value of angle POQ, this big angle. Now let's say angle POC is X and angle AOQ is Y. So this angle is also Y, COQ, and POC is also X. So 2X plus 2Y is equal to 180 degrees because these are angles on the same side of a straight line. So X plus Y is equal to 90 degrees. Now we have to find out angle POQ, which is angle X plus angle Y. And we already know that X plus Y is 90 degrees. So angle POQ is 90 degrees. Now in this example, it is given that a line AB is parallel to line CD. Now they are asking the value of angle X. You can see that angle X is this reflex angle and we have to find this value. We are given two angles in this diagram. Angle ABX is 45 degrees and angle DCX is 30 degrees. To make this problem easier, we should create another parallel line which is passing through X. And once we have created this dotted line, you can see that angle ABX and angle 1. Now you can see that angle ABX and this part of the angle X, this part, these two are interior angles on the same side of transversal. So their sum is 180 degrees. 45 plus x1 is equal to 180 degrees. So x1 comes out to be 135 degrees. And this part, if we take as x2, these are also same side interior angles. So 30 degrees plus x2 is also 180 degrees. So x2 comes out to be 150 degrees. So the total angle X is equal to 135 plus 150. To 85 degrees. Now here I'll also like to highlight that since x1 came out to be 135 degrees, if you look at angle 1, this comes out to be 180 minus 135, which is 45 degrees. So always this angle is equal to the alternate interior angle. We said that corresponding interior angles add up to be 180 degrees, but alternate interior angles to parallel lines are always equal. Similarly, this angle 2 is going to be 30 degrees. Either go by using corresponding interior angles or the alternate interior angles, you will get to the same value. Now in this example, we are told that AB is parallel to CD. So these horizontal lines are parallel. AC is parallel to BD. Angle EAC is 40 degrees. Angle FDG is 55 degrees. Angle HAB is X. So that is marked here. And we have to find the value of X. The question is focused at this point A. We have one value nearby X and the other value of 55 degrees very far from point A. So let us try to get this value of 55 degrees as close to A as possible. So we know that FDG is 55 degrees. If we go the corresponding angle for these two parallel lines AC and BD, these two are going to be equal. So this angle is also 55 degrees. Now if I take the other two parallel lines AB and CF, the corresponding angle, this part of the angle is also going to be 55 degrees. We know that this is 40 degrees, that is 55 degrees, and the total of these three angles is going to be 180 degrees because these are on the same side of a straight line. So 40 degrees plus 55 degrees plus X is equal to 180 degrees. X is equal to 180 minus 95, so 85 degrees. Now these were some of the examples which we discussed so that we understand the concepts in a more clear way. Now let us practice on some questions, the kind of questions which we see in competitive exams. In this question we are given that there are two straight lines PQ and RS and they are intersecting at a point O. The angle SOT is given, it is 75 degrees. And we have to find the value of A, B and C. So we can see that there is one angle 75 degrees, then there is B, then A, then 2C and then 4B. Now if you look at line PQ and on the left of this line PQ there are three angles 4B, 75 degrees and B. The sum of these three angles is going to be 180 degrees. So the first equation we can write as 4B plus 75 plus B is equal to 180 degrees. We can solve this equation for B. So 5B is equal to 105 degrees. B is equal to 21 degrees. Now we can look at the options and we can see that B is equal to 21 degrees is only in option A and we can straight away take option A now. However, if we want to find out value of A and C, we can do that by looking at sides of other lines. So if I want to find out A, I'll look at the line RS and the right side of this line. So to the right we have A plus B plus 75 degrees is equal to 180 degrees. So A plus B plus 75 degrees is equal to 180 degrees. We know the value of B. So we can find out the value of A. So the value of A comes out to 84 degrees. Similarly, if you look at the right side of PQ, it will be 2C plus A is equal to 180 degrees. And if you solve by putting the value of A as 84 degrees, you will get the value of C to be 48 degrees. So C will come out to be 48 degrees. Now in this question, it is given that L1 and L2 are parallel lines. L3 and L4 are parallel lines. And there is one angle marked between L1 and L4, that is this angle is 80 degrees. Now we have to find out the value of X, which is this angle. So here we just have to use the concepts of corresponding angles. So if that is 80 degrees, this angle is going to be 80 degrees. If this angle is 80 degrees, this angle is going to be 80 degrees. And now since these are on same side of L3, the sum is going to be x plus 80 is equal to 180 degrees. So x is going to be 100 degrees. So in parallel lines, whenever you see parallel lines, always remember those few properties of corresponding angles, opposite angles, alternate interior angles, sum of interior angles, and so on. In this question, L1 and L2 are parallel lines. Angle ABC is given. This whole angle, this is 80 degrees. If lines BD and CF, these two lines are parallel, and angle DBC, so the angle inside this angle is 30 degrees. We have to find the value of angle FCE. Now let's look at L1, L2 and the transverse line BC. If we only consider these three things, ignore the lines BD and CF, ignore these lines. If you only consider the two parallel lines and this transverse line BC, then this angle ABC, is going to be equal to angle BCE, because these are alternate interior angles and these are equal. So we know that angle BCE is 80 degrees. Now ignore lines L1 and L2 and only consider lines BD and CF. These are parallel lines, and the transverse line is this BC line. Now this angle BDC, this is equal to angle BCF, because these are also alternate interior angles. So angle BCF is equal to 30 degrees. We want to find angle FCE. So angle FCE is equal to angle BCE minus angle BCF. 80 minus 30, 50 degrees. So option C. In this problem, we have AB parallel to CD. And these four lines RD, SL, TM and AN, these are also parallel. We are given that BR ratio RS ratio ST ratio TA. These four segments, these are in the ratio of 3:5:2:7. So if you want to write the dimensions of these segments, it will be 3x, BR is 3x, RS is 5x, ST is 2x, and TA is 7x. So if you take their ratio, it will come out to be 3:5:2:7. Now we are also given that CN is 1.33 times BR. So if my BR is 3x, CN is going to be 1.33 times 3x, which is nearly 4x. Now we have to find the ratio of BF, FG, GH, HI and IC. Now as we have seen earlier in the concepts video, that when there are multiple parallel lines and there are two or more transversal lines, the ratio of their segments cut by those parallel lines is going to be same. So if I create a parallel line from B which is parallel to RD, now there are 5 parallel lines and there are these two transverse lines. BA is one transverse line and BC is another transverse line. So this ratio on the first transverse line, that is 3:5:2:7, this is going to be same on the second transversal line also. So the second transversal line is going to be having dimensions of 3y, 5y, 2y and 7y. So I hope you understand what happened here. Since the ratio of segments is going to be same on both the transversal lines, they are not equal. The ratio is same. So 3:5:2:7 ratio is going to be maintained on the second transversal line also. So we have the first 4 segments, but in line BC there is one additional segment which is IC. And we have to find the ratio of this segment also with other segments. However, since we know the first 4 segments and their ratio, we can look at the options and we can decide that the option is going to be B only, because the ratio for first 4 segments is 3:5:2:7, and that is not present in any other option. So we know the answer is B. However, let us see if we want to find out the 5th segment also, how we can do that. The hint is that we know the value of Cn. If we extend that parallel line and we create a new parallel line which is parallel to AN, and let's name this point as P. Now, since AN is parallel to PC and AP is parallel to Cn, AP is going to be equal to Cn. So basically this is a parallelogram, and in a parallelogram the opposite sides are equal. So AP is equal to Cn, and we know that Cn is equal to 4x. So the ratio of AP with the rest of them is going to be 4. And similarly, this IC segment is going to be 4y. So in the option B, you can see that the 5th segment is also in the ratio of 4. So you may not use that extra information for finding the 5th segment. When using the first 4 segments, you can already answer the question. So in that way, you could have saved additional 20 seconds. However, this is how you can find the ratio of all the 5 segments. That's all. These are some of the questions that we see in competitive exams related to lines and angles. That's all in this video. See you in the next one.